Good morning students and welcome back to science class. So last class we have been discussing about the fuels and about fire. Today we are going to discuss about the flame structure. That means when the matchstick catches fire or is burned, what happens? The heat is released due to burning of chemicals on the match head. They partly decompose the wood to form the wood gas. So the wood gas then catches fire and it produces a flame. And that flame has 4 zones. So the first zone is the blue zone. It is just near the base of the flame. Vaporized wax, it gets oxidized to carbon monoxide and burns completely with a blue flame in this zone. Then dark inner zone, surrounding the wick is the dark zone. There is no burning in this zone. If we pass a wooden splinter through the dark zone of the flame, it comes out unburned, showing that there is no burning in this zone. However, some unburned wax vapors are present in this zone. Then we have the luminous zone. In this zone, the flame hydrogen burns with a brilliant yellow flame. Burning hydrogen combines with oxygen to form water vapor. Carbon also burns in this zone, giving some luminosity to the flame, producing carbon dioxide. So some unburned carbon particles are left, which gives rise to soot. Then the next we have the outermost zone, that is the non-luminous zone. So in this zone is actually poorly visible and is slightly blue. It is the hottest part of the flame where complete oxidation of the fuel takes place, okay, or the complete oxidation of the carbon particles takes place, okay. So here we will see that there will be the 4 respective type of zones. The first being the blue zone, which is considered to be the hottest part of the zone. The next is the dark zone, and there is no burning in this zone, and we will see that if we pass a wooden splinter through this dark zone, it will come out unburned, showing that there is no burning in this zone. The next comes out the luminous flame. It burns with a bright yellow flame, okay. So the carbon particle in this particular zone, they will burn luminously to the flame, producing carbon dioxide. So some unburned carbon particles are also left, which gives rise to soot, that is the black substance. If you put any solid, any kind of you can say any utensil or anything like a spoon in that part of the flame, you will see that there is a black coating at the base of the spoon or the utensil. That is due to the formation of the soot. Then the next is actually the outermost non-luminous zone. This is poorly visible and is slightly blue. This is the hottest part of the flame where the complete oxidation takes place, okay. So here you will see if you see the structure here, you can see that the different colored zones are given from the base of the flame. A flame has 4 zones, you see. The first is the blue zone, then comes the dark inner zone, and then comes the luminous zone and the non-luminous zone. So these are actually the 4 different types of the zones present in the flame, or we can say these 4 zones constitute the structure of the flame, okay. So please go through your book. In your book it is given very clearly. The diagram is also given there, okay. Then next you see characteristics of a good fuel. It should be cheap and readily available. It should be easy to store. It should be burning at a very slow rate and its combustion should be controllable. It should have a low ignition temperature and it should produce very small amount of residue such as ash. It should have a high calorific value. It should not produce gases which pollute the air, and it should not produce any hazards during transportation. So here you can see there are 8 points which are told or discussed about the characteristics of a good fuel. So today we will touch only these 2 topics, or we will discuss about only these 2 topics, that is the flame and your structure of flame and the characteristics of a good fuel. Next class we shall be discussing about the classification of fuel and then fuel efficiency, okay. Classification of fuels, actually you have We already went through it in the earlier classes. Means there were some topics which are related to it, like solid fuels, which were solid fuels like coal, then coke, okay, charcoal, wood. These all are actually solid fuels which are present in a solid state at room temperature. Then liquid fuels, the fuels which occur at a liquid state at room temperature, like you can say kerosene, then your petrol, then diesel, okay, liquid hydrogen. These all are liquid fuels. And gaseous fuels means the fuels which occur in a gaseous state at the room temperature. For example, water gas or producer gas or coal gas or CNG, gobar gas, etc. So these are actually different classification of fuels based on their state which they exist at a particular room temperature. So my dear students, we have gone through the classification of fuels, characteristics of a good fuel, and then the structure of a flame. So we need to go through this all the points very attentively, and then please go through your textbook also. The same thing is written again but in a little bit different way. That one also, if you study, that one also you'll go through it, so that it will help you to understand this one in a very wider sense. And please draw the structure of candle flame and the 4 zones of a candle flame. You need to write what are the 4 zones and what do they actually describe about the 4 zones. Okay, and please make a note about the characteristics of a good fuel, which highlights here 8 points. In exam you may be asked 5 or 6 points about the characteristics of a good fuel, and next based on the physical state how the fuels can be classified, that is your solid fuel, liquid fuel and gaseous fuel. Please prepare a note on these 3 topics in your copy. Okay, so that is what we will that is what we have learned today. So I am winding off here, and in the next class we shall start with a new topic, that is fuel efficiency. Thank you.